Hi, this is your host. The efficiency of a boiler system is one of the most important factors to consider when designing a heating or hot water system. The choice of material used in the heat transfer surfaces has a major impact on overall efficiency. Advanced materials that are resistant to corrosion and fouling can significantly improve the performance of a boiler system. In this context, we've seen many innovations in recent years regarding advanced materials for boilers. So what are the new trends, and how do they improve the efficiency of boilers? That's what we'll discuss today. For more than 30 years, the standard material used for water walls and other superheated surfaces has been 18 chromium steel. However, this material has limitations in terms of creep resistance at high temperatures and corrosion resistance in high-pressure steam and hot water applications. Therefore, for large packaged boilers, manufacturers have started to use advanced materials such as Incoloy 800 HT, which is a high-temperature resistant alloy developed by Special Metals Corporation. It offers superior strength and creep resistance compared to 18 chromium steel at temperatures up to 650 degrees Celsius. This allows for higher thermal efficiencies because it can be used for higher temperature applications. Additionally, it has excellent resistance against galvanic corrosion and stress corrosion cracking, which further improves its service life. Another advanced material that has gained popularity is Nextel 611, which is a high-temperature resistant ceramic fiber developed by Honeywell. This material is particularly well suited for low-temperature applications such as condensing boilers. Nextel 611 can withstand temperatures up to 1200 degrees Celsius and has excellent resistance against thermal shock and corrosion. Compared to metal alloys, these ceramic fibers offer lower thermal conductivity, which results in less heat loss and increased efficiency in condensing boilers. To reduce the weight of the heat transfer surfaces and facilitate transportation, manufacturers have also started to use advanced materials such as aluminum and copper. These materials have higher thermal conductivities than steel, which means that they can transfer heat more efficiently. This results in smaller and lighter heat transfer surfaces, which reduces the overall weight of the boiler. For example, Cleaver-Brooks boilers use aluminum water tubes with an enhanced geometry to increase the heat transfer coefficient. This allows them to produce more steam with less fuel compared to traditional steel boilers. Manufacturers have also started to use advanced coatings to improve the efficiency of heat transfer surfaces. For example, MHI has developed a new coating for water wall tubes that improves the heat transfer coefficient by up to 15%. This is achieved by creating a micro-sized roughened surface that increases the contact area between the water and the flue gas. Another example is the use of silicon carbide coatings on superheater surfaces. These coatings have been shown to reduce fouling and improve heat transfer, which increases the efficiency of the superheater. Furthermore, manufacturers have been exploring the use of nanofluids to improve the heat transfer coefficient in boilers. Nanofluids are fluids that contain nanoparticles that are suspended in a base fluid, such as water or glycol. These nanoparticles have a significant impact on the thermal conductivity of the fluid and can increase the heat transfer coefficient by up to 30%. However, the use of nanofluids in boilers is still in the experimental stage, and there are challenges that need to be addressed before they can be widely adopted. One of the main challenges is the stability of the nanofluids over long periods of time, as the nanoparticles tend to aggregate over time, which reduces their effectiveness. Another trend in the use of advanced materials in boilers is the use of computational fluid dynamics, or CFD, for optimization. CFD is a computer simulation tool that can be used to predict the behavior of fluids under various conditions. It can be used to optimize the design of the heat transfer surfaces by providing insights into the flow patterns and heat transfer characteristics of the boiler. For example, CFD has been used to optimize the geometry of water walls and superheaters, resulting in improved heat transfer and combustion efficiency. Overall, the use of advanced materials has significantly improved the efficiency of boiler systems. From high-temperature resistant alloys to ceramic fibers, each material has its own unique properties and advantages. By understanding the different materials and their applications, engineers and designers can select the best materials for specific applications, resulting in improved efficiency and performance of boiler systems. As technology continues to advance, we can expect to see even more innovative materials and applications in the future. If you enjoyed this video, don't forget to give it a thumbs up and share it with your friends. Also, if you'd like to learn more about boilers and other advanced materials, subscribe to our channel for more informative content. Thank you for watching, and we'll see you in the next video.